to my channel. So in this video I'm going to try to solve this problem, do some left coding work. At the same time I'm going to follow the general steps you should follow in a coding interview when we try to solve this problem. So first of all, let's try to race through this problem. You're given an n by n 2D matrix representing an image. Rotate the image by 90 degrees clockwise. So you have to rotate the image in place, which means you have to modify the input 2D matrix directly instead of allocating another 2D matrix. So let's take a look at the constraints. It says that it is n by n matrix essentially, and the n is anywhere between 1 to 20. So for sure the matrix is not gonna be empty. And the value of so the numbers within the matrix is between minus 1000 to positive 1000. So that's pretty much about this input constraints. So far I don't think there's too much of the room to think about edge case. So let's see how to solve this problem. So for the problem, I think it is going to be like a n square solution. When I say n square, n is essentially the size of the matrix. So it's n by n matrix, and the runtime is going to be n squared. So it's kind of like an onion peel. What we are going to do is, so let's take a look at the example 2 maybe. So we have two layers of onion, so outer layer, which is something like this, and the inner layer. So we are going to do a rotation. Let's say for the outer layer we have 4 parts: this part, this part, this part, and this part. So we are just going to do the rotation layer by layer, like peeling the onion, and that's pretty much it. So having said that, it's mostly about getting the right x and y and change the value in place. So it's actually getting the value for each of the layer, and each part we get the corresponding right x and y, and then change the value in place. And yeah, so mostly about getting the right x and y here. So having said that, let's do some coding work for this one. So first of all, we need to have we need to know how many layers we have. It would be something like matrix.length. So this is the layer is equal to matrix.length divided by 2. So if it is 3 by 3 matrix, so actually we just need to do the outer layer. If it is 4 by 4 matrix, we need to do 2 layers, so something like that. If the length is odd, then we don't need to do the inner layer, because essentially for the innermost layer there's only one number. So this is how many layers we have, and for the parts, so for each part, so for what is the part for each layer? So it is going to be so for example, for this layer the length of the part is 3, and for this one it is 1. So it's really decided based on, okay, so let's see, what is that? For the out layer we have like a for loop within another for loop. The outer for loop is actually looping through the layer, and the inner one is looping through the different parts. So let's see, int I would say current layer is equal to I and equal to 0. Current layer is smaller than layer, and the plus the current layer. So that's the current layer. And the next thing I need to have is the index of the part. I would say this is int idx is equal to 0, idx is smaller than So like for this part is actually, so how to compute that? So this would be, let's say we have the, let me have the n defined here. So this is n. So this would be n, if it's going to be, if it is n minus the current layer. So if it is the current, maybe something like n okay, so it should be minus, so like for the outer layer we have the 3, inner layer for this one we have 1. So this would be, okay, so I know it. So it should be smaller than current layer and minus 1. So it should be 0. So this one, let's say for this layer we have n as 4 minus 0, then minus 1. So it should be 0, 1, 2. Okay, yeah, so that should be this. And then plus idx. So for the outer layer, the for loop is looping through the layer. So it's something like this one, and then this one, for example 2. And then for the inner, it is actually for the inner for loop is actually looping through the different parts within the layer. So like we have 4 parts of it, and each part, the length is representing as from 0 to n minus 2 times layer minus 1. So it's like for the outer layer, there are 4 parts, and the length of each part is going to be so for example, for the outer layer, the length of the first part is going to be this, second part is like this, so they have the equal length as well. So we are going to try to get the corresponding cell and then do the assignment. So let's say we have num1 as equal to, this would be matrix, this is a layer, so if it's the idx, then it is going to be, well, it should be current layer, and then the so this will be current layer and idx. So it's idx plus the current layer, I think. And then we have the num2. Let's say for this one, we are going to get this, and this, and then do like a rotation. And then for the second one, it is so the row number. So what is the row number? So row and the column. So it's on the last column. It would be minus 1 minus the current. So this one, x and y. This is a y, which is a column index represented as this one. And for the column, it should be the current, well, it should be n minus 1 minus the current layer. Okay, so for int num3, it would be let's say for this one, it should be like this. So the row number would be n minus 1 minus the current layer, and the column would be Alright, so the column will be n minus 1, and then minus the. Okay, so we haven't actually included the index, which is not right for num2. So for num2 it should be for num2 I think the column, so the column is fine, but the index is not correct. So the index actually, it should be idx here, okay? idx plus the current layer. And for num3, it's actually row is just this one, and the column is minus 1 minus current layer. It should be minus the idx here. Well, and the num4 should be matrix. So for num4 it would be something like here. So it's actually the column is just the current layer, and the row is going to n minus 1 minus the current layer, minus 1 minus the current layer, then minus the idx. Okay. Alright, so now we are going to do like the rotation on top of it. So you're going to have this assigned as num1, and then we have this as num2, then we have this as num3, and we have this as num4. Yep, I think that's pretty much it, but let me just double check about the x and y here. So for num1, it's the x, the row number is essentially the layer, and the column is the idx plus the current layer. Yep. And the num2, it's for the column. It's actually pretty static. It's n minus 1 minus current layer. For the row number, it's idx plus the current layer. Okay. For num3, it's actually this. The row is, if the layer is fixed, then the row is fixed. And then the column is n minus 1 minus current layer minus the idx. Okay. And for the last one, the column is fixed, which is current layer, and then the row number is n minus 1 minus the current layer, then minus the idx. Okay, let's try to give it a shot. Okay, so it seems like it's accepted. Let's do some other examples. Okay, cool. Let's do a summation on top of it. Okay, so it seems like everything works well for this problem, and that's it for this coding question. If you have any question regarding the solution or regarding this piece of code, feel free to leave some comments below. If you like this video, please help subscribe this channel. I'll see you next time. Thanks for watching.